Okay, so you've heard of your computer's brain, the CPU, right? Of course you have. But there's another secret genius hiding inside your machine, a hidden artist that's responsible for literally every single thing you see on your screen, from your desktop to the incredible worlds in your favorite games. Today, we're going to meet that artist, the GPU.
All right, so to really get what's going on, you've got to look super close at your screen. I mean, really close. It's not one solid image. It's actually a giant grid, a canvas made of millions of tiny little dots of light. We call them pixels. A normal 1080p screen has over 2 million of them. A 4K screen? That's over 8 million.
Now, for your computer to show you, well, anything, even just a still photo, it has to decide what color to make every single one of those millions of pixels and then paint it. It's a huge, huge painting job that has to be done perfectly every single time.
But here's where it gets kind of mind-bending. When you're watching a video or playing a game, that entire canvas of millions of pixels is getting completely repainted. Not just once, but 60 or 120 or sometimes even more times, every single second. How in the world is that even possible? Well, the answer lies in a totally different way of thinking, and it's all thanks to the GPU.
All right, so the best way to wrap your head around this is with an analogy. This isn't about one processor being smarter than the other. No, it's about having two very different specialists for two very different jobs. I want you to think about it like this. One brilliant brain surgeon versus an entire army. So on one hand, you've got the CPU, your computer's main brain. It's that brain surgeon. It has just a few incredibly powerful, super smart cores. They're built for handling really complex problems that have to be solved in a specific order, one step after another. But the GPU, it's that army of painters. It has thousands, literally thousands of much simpler cores. Each one is designed to do a small, repetitive job at the exact same time as all the others.
Let's really nail this down. Imagine the job is to paint a giant blank wall. How would our two different workers handle it?
The CPU, our master painter, would start in one corner and carefully paint the wall, stroke by meticulous stroke. The result would be perfect, sure, but it would take forever. The GPU's method is completely different. It tells each of its thousands of painters, you take this tiny patch of wall and this can of paint. And then they all go at once. The entire wall is covered in a flash. And that is exactly how a GPU paints your screen full of pixels. And that, right there, is the GPU's superpower. It's called parallel processing. It's the art of taking a massive, overwhelming problem, like coloring 8 million pixels, and breaking it down into thousands of identical little mini problems, and then solving all of them at the same time. This is the simple but brilliant idea that makes all modern graphics possible. But here's where the story gets really interesting. This army was created for one job and one job only, to paint pixels. But pretty soon, some very smart people realized that its special skill could be used to solve a whole new world of problems that had nothing to do with graphics. You gotta remember, the GPU was really born out of the need for realistic video games and, just making our computer desktops look nice. Its entire reason for being was to be that army of painters for the pixels on our screens. And for a long time, that was pretty much its only gig. But then, other people started noticing. 3D animators realized that rendering millions of tiny triangles in a movie scene was a parallel task. Video editors figured out that applying a complex effect to thousands of frames of video was a parallel task. And scientists, they realized that running massive weather simulations or sifting through mountains of data was also, you guessed it, a parallel task. But the biggest revolution of all was still to come. Okay, this is the key. The AI revolution we're all living through right now, it's powered almost entirely by GPUs. You see, training an AI model, it's really just doing billions and billions of simple, repetitive math problems. It's a brute force problem on a scale that's hard to even imagine. And that is the exact job description that the GPU's army was born to do. So what's the big takeaway here? It's not about the GPU being better than the CPU, or vice versa. It's about realizing that modern computers need a team of specialists, and having two different kinds of brains is way, way better than just having one.
I mean, think about it. You wouldn't ask an entire army to perform delicate brain surgery, right? And you would never ask a single surgeon to paint an entire stadium. It's about the right tool for the job. The CPU and GPU aren't competitors, they're collaborators. They're a team, each a master of its own domain, working together to make everything run smoothly.
So, at the end of the day, it's pretty simple. The CPU is your serial processor. It's the project manager, handling all the complex, step-by-step thinking that runs your operating system. Meanwhile, the GPU is your parallel powerhouse. It's the specialized workforce that does all the heavy lifting for graphics, for video editing, and especially for training AI. And all this leaves us with a pretty fascinating question to think about. We built this digital army just to make our video games look better. Then, we accidentally discovered it could revolutionize science and give birth to artificial intelligence. So as the problems we face get even bigger and more complex, what's next? What new, unimaginable challenges are out there just waiting to be solved by this army of digital thinkers?